All right, everyone. Thanks again for joining my talk. I'm not sure whichever places you're joining, if it's a good evening, good morning, or good night for you. So, so I'm going to talk about Python-driven portfolios building theory and practice for efficient investments. So I'm going to cover a bunch of interesting stuff in theoretical aspects as well as practical approach of the stock and some quick pointers here, like if you're already have some knowledge on finance, then I think it will be easy for you to follow the flow of the talk. Otherwise, if you're new to the finance and all that, then I think it shouldn't be a problem. But I believe that by the end of the talk, you are still able to connect the dots, whatever we have discussed here. Okay. So some shameless promotion about me. I'm basically a self-taught data scientist and analytics manager, where I lead the team of data and analytics team at my work. Apart from my profession, so I've been involved in a lot of open source communities where I perform different roles and responsibilities in each of these organizations. So you can look at some of the organizations which are listed in my slide. And the other thing is always look for an opportunity to share my knowledge. So wherever I get a speaking opportunities, I always like to speak and share my knowledge on platforms. Yeah, also wear two hats here. On one is on industry side as well as on something. I also have a hat on academic side as well. So I also mentor on commercial platforms and community platforms like Prasad, Kaggle, and TalkMatter. And if you want to connect me or if you have any feedback that you want to give about my talk or anything, these are my social handles. Feel free to write it over there, and I'll be definitely responding to each and every message that I receive on these platforms. So without any further delay, let's get started. So they say money talks, but all mine ever says is goodbye, because that's why I'm here today to talk and share or learn about building efficient portfolios. By the way, this was a joke, but it's a fact. Okay. Uh, and yeah, one important thing here is disclaimer. So my talk does not provide any financial advice. Neither I do not claim as a financial expert here. So the purpose of this talk and the object of this talk is to share knowledge and encourage learning. So it's purely an educative purpose. So take everything as a grain of salt, and if you like it, then play around with it your own financial data and see how to get the results and everything. So let's start with a portfolio. What exactly is a portfolio? So a portfolio refers to the bucket of a financial instrument that an investor or individual holds. So it can be a bunch of different financial instruments like your stocks, bonds, commodities, which you have seen on my slide, or like mutual funds, etc. So the objective of a financial portfolio is to generate wealth and over the investing over the area of investing period and achieve its financial objectives. So that's the main goal of a portfolio in portfolio management test. So this is one of the key concepts in our main topic. So that's the reason why I thought of starting out with a portfolio here. So before we actually get into the main theme of our topic, I just want to highlight you about the man behind the topic which we are discussing. So there he is, Harry Markowitz. So Harry Markowitz is a famous American economic scientist, and he's a father of a modern portfolio theory, which we are going to talk in the overall presentation, right? So and Harry Markowitz is a very popular figure. If you go to Google and find, just quickly do a Google quick search, right? You'll get a bunch of tons of information about him. So that's popular he is, and he won a Nobel Prize in 1990 in economic science for developing the modern portfolio theory. So that's a great thing. And so in the world of investing, so realizing how risk is so important alongside with returns is also crucial. So that's what Markowitz has spent his life in studying this balance through modern portfolio theory. Yeah, so yeah, And some of his work has been like popular concepts like diversification, overall portfolio risk and returns, which will be seen in detail in the next coming slides. All of these are like very popular concepts and very widely used in industries of like organizations. So that's popular these things are. And the saddest part here is the OG of finance, that is Harry Markowitz, is no more. I mean, like he has been recently passed a couple of months back, but his the great work has been like greatly appreciated and it's been widely used in industries these days. So there comes our main topic called modern portfolio theory. So there are a lot of traditional definitions which you can see for MPTP on Google, but to put it in a very simple way, right? It's a framework for evaluating risk and return. Now you might be wondering, okay, I'll skip about my self intro here, but okay, let me talk about the important things here. So yeah, I'll start with the disclaimer here. So again, so the talk is not to provide any financial advice. Neither I claim as a financial expert here. So the main objective and the overall objective of this talk is to share knowledge and more of on an education purpose, so that if you feel interested, you can play around with it. So there's no way related to provide any financial advice from this talk. Yeah, so let's start with a basic concept called portfolio. So portfolio refers to bucket of different financial instruments that an investor or an individual holds. So it can be like different financial instruments, like your stocks, bonds, commodities, like your mutual funds, debts, right. So the overall the object of a financial portfolio is to generate wealth over investing and achieve its financial objectives. So that's what the portfolio and portfolio management things do in real time. So which is one of the key things in our main topic. So that's the reason why I started with this concept. And again, so some of the pointers which I told you earlier while I was mute. So what I was saying is, if you are familiar with the finance, right, then it will be easy for you to follow the flow of the stock. If you are not familiar with the finance, I believe that by the end of this session, you are still able to connect dots for sure. So that's how. So I'll not talk about more complex theory or more complex stuff, terminologies. I'll try to put it. I'll try to put it or explain everything in a very simple way so that you can grasp the context easily. Okay, so before we are going to talk about the main theme of our topic. We need to understand the man behind this topic. Man behind this, it is nothing but Harry Markowitz. So he's like popular American economic scientist, and he's also called as a father of modern portfolio theory. And for that, he won in Nobel Prize in 1990 for developing this amazing modern portfolio theory. So imagine in the world of investing, right? So realizing how risk is important alongside with returns is crucial, right? That's key. So this man has spent his entire life in studying this balance between the risk and return. So his work has been popularly recognized and it's been widely used in industries till today as well. So that popular his work is all about. So you'll be seeing the concept like diversification over overall portfolio risk and return. So all of these things you'll be seeing practically like lively to the next couple of slides as well. And the saddest part here is so the OG of finance, is no more. I think a couple of months back he passed away, but his work, the way he worked, the work he has done in the quantum finance and investment analysis is widely appreciated. So here comes our main topic called modern portfolio theory and MPT. It's like so there are a lot of traditional definitions you can see on the internet about MPT, but to put it in a very simple way, right? It's a framework for evaluating risk and return. Some of you might be wondering, it sounds very simple, but what you have to understand is prior to MPT, there was no standardized methodology or a framework for evaluating risk and return. So that's the key thing about MPT, which has brought a lot of changes in the industry. And again, it's a mathematical process which allows users to examine returns for a given risk level. Of course, there's a lot of underlying mathematical algorithms, formulas, and techniques which are involved in order to achieve this thing. But don't worry, I'm not going to show you about all those complex formulas or I'm not going to show you any mathematics here because I really don't want to scare you on. Instead, I'll show you things in a very simple way with a simple piece of Python code that you can get things done. So MPT, and it assumes that all investors are risk averse. Let's for instance, if you have a returns of the for low variance portfolios and a high variance portfolio with same returns, right? Definitely, investor will try to choose the less investment, less low variance returns, right? So end of the day, nobody wants to go for a high risk or a high returns, right? Because nobody wants to lose the money. And the beauty of MPT is it encourages diversification of assets. So, for instance, if you have a high variance portfolio X and with diversification assets like Y and Z, so your X Y Z will not have any direct correlation, and which puts in a very diversification assets, and that will give you a great number of returns instead of losing everything. So that's the beauty about the diversification. So that's main the crux of MPT here. And so when it comes to industry, right, it's a key tool for a lot of asset managers and robo advisors, so because they use to build strategies of buy and hold strategies with us MPT series. So that powerful. This is in real time as well. To explain you in a very simple process about MPT, right? So this is a simple example where you can try to understand the MPT process here. So imagine that we have a $1 million and that splits between with fund X and fund Y, which means that you are investing $700,000 in X fund and you are trying to invest $300 in fund Y, right, with an expected return of 7% and 10%. So now how this calculation will happen is something like that. If you look at this breakdown, which I am which I am trying to point out here is so we have invested $700,000 with an expected of 7%, and which is when you calculate this, you get the $49,000 out of it. Similarly, for $300,000 for Y fund with a 10% expected return, you get a $30,000 expected return. So when you sum up this both expected return, right? So it's 49,000 and 30,000, which is $79,000 combined expected return. And then when you divide this combined expected return with your total portfolio amount, so this is your expected portfolio return percentage. So this is which is where we are trying to get your combined portfolio percentage of value for $1 million investment, which has been split into two different ones. So that's how it works in the real time with a simple example. But again, this is a very simple example, but in real time, we do have a lot of complex data that I'll show you when we move on to the demo part. So that's how exactly the process works of MPT in real time. And yeah, okay, I think I should change. Right. Okay. Again, when it comes to, as I mentioned, there are a lot of mathematical modelings are there in MPT. So we focus only on the foundation of mathematical model because there's a lot of complex things which I don't want to discuss or which I won't confuse. We'll start with the only financial aspects which are really important to understand the intuition behind the MPT theory. So once you get a fair understanding on this foundation, I think you can gradually build upon or go for this advanced model and play around with it. So the objective is to focus only on the foundation aspects in this talk. So we'll start with the first risk and expected return. So this is exactly how we try to derive. These are the key pointers where we try to identify the risk and expected return during our MPT process, risk aversion, as I mentioned. So every investor is aware of the risk associated within the MPT portfolio. So that because if they want to get more returns, so they will be high risk. If they want to get less returns, that is less returns. So relationship of a risk and returns will work similar. So when you are trying to expect more money, then you definitely have to take the more risk. So that's how that risk and return relationship closely works in a modeling process. And and while so risk can be measured by the standard deviation of a returns, assuming certain parameters how returns are distributed. So standard deviation plays a very key role in terms of identifying our expected and risk and expected returns. While we are building a portfolio model, right, optimization model, we'll try to calculate both the portfolio return and the portfolio volatility. So the portfolio return is nothing but your the combination of a consolidation of the results of your individual assets, which has been proportionally distributed in your assets flow. The one example which I have seen earlier. So the volatility is nothing but how much risk has been associated with within those assets. So it's like how two assets are correlated each other. So this is where you have a more volatility and more risk because if they are correlated, it means that either they are in a super fast increasing trend or either there can be a super fast decreasing trend. So this is where your risk lies because there is no diversification involved. So that's how the risk and expected return factor works. Don't worry about all of this theory, but when we try to practically put it everything in a code, right, you when you see the code part, I think you will be able to clearly get out of what we are trying to do with or the terminologies or what we try to cover. Everything you will see in the practically when we move on to code. Again, as I mentioned, diversification is really important. It's the crux of modern portfolio theory because it helps us to eliminate or reduce the risk. When we have a diversified asset, so the impact of one asset may try to fulfill the back with other diversified assets. So one asset loss can be tried to input in the other asset so that you will get a balanced returns rather than losing everything. So that's how the diversification risk works here. And yeah, so as I mentioned, it reduces the risk. So risk can be two types here, like idiosyncratic risk and non-systematic risk. So idiosyncratic risk is something where diversification works well because it specifically focused on specific assets. So this is where you can put the diversification and try to eliminate the risk. But when it comes to systematic risk, right, it's something like where it has impacted the entire market, like your entire stock market has put it in the risk. So this is where you cannot try to put the diversification. It's very hard to put a diversification for the entire stock market issue, right? So you cannot work on a systematic. And in order to build a very diversified portfolio, right? So it's good to include your assets in various industries, various instruments, and at the various risk levels, so that your portfolio is well diversified. So that's what exactly the portfolio managers and robo advisors will do your money when you try to invest in different assets portfolio. And as I mentioned, so perfect positive correlation. If there is a positive correlation in your graph, it means that when there is a high level of risk, because when there is a positive correlation between different assets, it means that either they are in an increasing trend or whether it can be a decreasing trend. So there is no diversification involved here, right? So this is where you see a lot of risk here. But when you hold assets, so when your assets are moving in an opposite direction, which means that whether they are negatively correlated or moving in other way, so this is where your diversification works well because when you have a issue with when you have risk in one asset and when you have not in other assets, you try to put that into this so that you can well diversify and you can hold that asset and that will give you a beauty of returns rather than losing everything. That's what the diversification is all about. And so when you are trying to identify the risk and return levels of your portfolio, so we try to plot a visual called efficient frontier, so which where we are trying to figure out how risk optimization how risk optimization rates are used to get the returns what we are expecting. So this plot helps us to identify that how much risk optimizer involved and how much returns we are getting it. So the x-axis basically shows your risk factor, and the y-axis basically shows the return factor here. And you can look at the, so this is what the line is nothing but the efficient frontier line, and you can look at this vision as a parabola. It's the shape of a parabola, right? So, so the line above, on and above are nothing but your optimized portfolio that generates a return for a specified level of risk, and line below points are nothing but not optimized, and that's how the efficient frontier plot works. I think this is pretty much theory that I have because I don't want to bore you with a lot of theory. So let me show you some action now that how we can build a efficient frontier with real time. Let me go back to my code. Uh, okay, there it is. It should be somewhere here. Oh no, not. Sorry, my bad. So yeah, so this is a notebook which I've created for this demonstration. So you can see that. You will need to walk. The objective is to walk you through the end-to-end process of moving portfolio theory. So as usual, I imported necessary aspects like your for data manipulation, performing some statistical calculations, and performing some scientific computation functions and plotting for that. So I imported all of these different libraries here, so which you can see. So when it comes to data gathering, so it has five diverse ETF assets, which has a treasury bond, which has a price of gold, which has a S&P 500 index, which has a Nasdaq large cap technology index, and also the emerging equity market. So I got data from all these different five ETF assets. So how I am pulling this real-time data is through with a Yahoo Finance. So the data period which I'm pulling is from 2018 to 22 because I just pulled the 4 years data. Initially, I thought of pulling it 10 years, but no, considering the computation power of mine and all my personal system, so I did just 4 years data and all. So that's it. So next, what I'm doing is I'm trying to get this data, retrieve this data real time. So for that, what I have done is I've written a custom function where I am passing my assets data, where I'm passing my start and end date of the data. And so when I get this, so I get a lot of different columns of data. So it can be a volume, it can be a date, everything. So, but instead, I was just focusing only on the adjusted close value because adjusted close price is something that which I'm really interested to understand how these prices have been moving and how these prices are fluctuating. So that's the reason why I'm picking only the adjusted close price. So I passed my tickets here, started everything, and everything I have saved in the data called asset data. So once I pull this, so there I can see that my assets data for all these five different assets. So next thing is what I'm trying to do is trying to calculate the risk and return. So which I've shown you here. So as I mentioned, so investors always try to prefer with less risk portfolio when they have same returns, right? When they have more risk and higher, lower risk with same returns, people always try to prefer the less risk portfolio, right? And there's only a slight possibility that people might go with the high expected risk, but only when they promise or when they try to see that their return are also getting for high. This is a slightly rare case in real time. Next, what I'm doing is I'm calculating the daily returns. So since I got a daily prices of the daily prices of adjusted close, so next what I'm trying to do, I'm trying to convert this daily prices into log returns. So for that, what I've done is I've quickly written this function called calculating daily result, and with np.log function, what I'll do is I can convert this daily prices into log returns, and I put those daily returns into a variable called daily in a variable called daily returns. My so you can see these are my daily returns value. Similarly, I've also done for the annual returns as well. It's pretty same. So just pass my annual return value, and there you can see my annual return values. So next, what I've done is I try to visualize and see how my daily returns looks like. And if you see, this is how my daily returns plot looks like for all the 5 steps. So you can see, so it's simple. So with a matplotlib plot function, I could just pass my index and values. So and there you can see the daily return for all my years, and you can see the fluctuations of all these different assets, right? For example, if you see the S&P 500 has the highest fluctuations graph, especially the 2020 mid, followed by VWO. So you can see, so these kind of insights you will try to get it from your daily rhythm calculation. That's what. Next, what I have done is I have tried to calculate the covariance returns, which means that I try to bring the covariance matrix values of daily return. So this is what my daily return covariance. And similarly, I have also got the covariance for annual returns as well. So the reason behind for giving 252 is nothing but, so in 365 out of 365 days, we only have 250 days that considers as a trading days where your markets will be open. Rest of the days will have holidays and everything. So next, what I'm doing is next I'm trying to declare weights with this simple piece of code. So basically, what this code generates is it basically generates a random set of weights that can be allocated with allocated to the funds within a portfolio. It's like where you're trying to put your all of the money into the assets of a different assets within that portfolio. So, so the reason, and the thing is, when you try to sum up all of these weights, right, it equals to one. So that's the thing. If your weights are something where you're not trying to get it, it equal to one. So this is where you're missing. So I've just written the formula when I print the weights. So this is what the weights I got it from my follow all of these edges. So now that we got all these weights, so I'm trying to calculate my expected portfolio return, but simply by passing my daily return means and weights, so I got my expected portfolio return value. And similarly, I've also tried to get the variance values as well. It's simple that where I try to pass the three parameters with the np dot function, and also so here where I'm trying to do is, so where in this case where I'm weight has been transposed from column index to row index. If I don't transform the weights here, then it will be a big mess where I have to calculate the variances. Where I have to calculate the weight for all the variances for all the weights. So that's again big mess here. So instead of that, so I just simply passed all of these things in this particular function, and there I got my portfolio variance and volatility values. So summarize it. So we have what we have done is, so we have basically fetched the data and we have tried to calculate the portfolio variance and expected return of our values on one single weight, only on one fund singular. But if you, in order to get a more optimal solution, we need to perform this same iterative process on thousand number of weights, so that we'll get a very understanding of it.
Oh,
So
hey, I'm
yeah.
sorry to interrupt you, but we're at time. Would you just like to direct your questions to Discord?
All right, so I'll quickly show you what I want to show on the final plot. So I'll run the portfolio simulation, and once on all these assets, just give me a 3 minutes, Steve. I'll just wrap it up.
Uh,
So 2 minutes, I just want to show you the final plot visual that uh, mm, is it fine?
yeah, we're really at time. I mean, I'm sorry, but like,
All right. So basically, this is what my the final outcomes which you plotted, right? So you can see the efficient plot for this is your optimal short ratio and your portfolio expected returns. Based on this, people will try to make a better investment decision whether they want to hold or sell. So I can share the notebook and feel free to play around with it. So my bad that initially I was in mute. Otherwise, I would have covered all of this interesting stuff. Yeah, I'll be happy to take questions in the Discord, and yeah, these are some of the references if you want to play around with it. Yeah, thanks again, and if you have any feedback and if you want to reach out to me, so feel free to get in touch with these things. Yeah, now.